but he made sure to take pictures of his setup, and his setup just looks like a botnet. It's literally like 12 like old Blackberries all connected together via one power bar. It's like the most shaggy setup. But he couldn't do this investigation with iOS because iOS mostly doesn't provide the raw binary files. Like you can't really find them. So you couldn't reverse engineer anything.
Oh, interesting stuff.
Yeah, but let us get into the first couple slides here at least. But so CHADS Network Security and Privacy Cohort, week 2. I'm Sasha, and that's Manan over there. He did the first presentation. Thank you for them. I was unavailable at that time because I was at CFB Valcartier, as you can see in the bottom there. CFB is Canadian Armed Forces Base. Let me see, actually. Yeah, introduction. Yeah, CFB is Canadian Armed Forces Base because I am part of the military. A little bit about my background. I am obviously a CHADS member. I've been a CHADS member for like a year. I've attended a lot of CTFs. I don't think I've ever placed because I don't really go there for that. I usually go to see whether there's some new things for me to solve. Because once you see like your 500th binary exploitation question, it gets a little repetitive. On the civilian side, I've been working as a part-time cybersecurity analyst, fully online for the past 9 months, almost coming to a year. So that's very exciting. On top of that, I do research at the university, also in this sphere. I started with cryptography and looking into efficient ways to compute sets without disclosing a lot of information about what's outside the set. Afterwards, I switched to network security, and I was working under Dr. Ali Chu. I was working on VPN fingerprinting. So if you ever have a question about VPNs or fingerprinting or networks, I am crazy over that. Where in that project, I was taking a look into fingerprinting, what you're doing even while you're using a VPN. And the results are also staggering to the point where you just might as well not use a VPN. But and then additionally, right now, I work as a research assistant. I went back to the cryptography laboratory. We're currently working on a privacy-based research project spearheaded by a grad student from Munich. She received a huge grant to create a new taxonomy for how to classify privacy breaching events, because in the privacy and security kind of world, a lot of people focus on security and then they miss out on the privacy part of it, and then they call it a little bit of a subfield that nobody looks into. But especially in the EU and stuff, the concern with privacy is huge, as you can see with the GDPR and other relevant geo laws. And that project revolves around the taxonomy has already been created. We're just trying to look into literature and use it for a bit and create a data set for others to use it, because it's probably going to be a very huge breakthrough in the field after we publish the paper. But yeah, now that you guys know everything about me, and then for the military, I am part of the COATS program. So I basically teach cadets. I have over 500 hours in ground school, so I know a lot of things about airplanes as well, and that's what I teach on a daily basis. Okay, that was a lot about me, so I want to get to know you guys. So Vish, I believe, if you could just give me a summary. Oh, also I'm third year U of A, fourth year, I guess. So just give me a summary of what you do and stuff so you can get better feel for who's in this mentorship program.
Hi, I'm Vish. I'm into computers. I like my code bases that the code languages that I know are Python, HTML, CSS, JavaScript, and I've been getting into C++. I've been exploring my code options, and I would like to get into cybersecurity. Yeah, is it? Is that good?
Yeah, for sure. What year were you?
Second,
Second year? Like going into second year?
going into third.
And are you general CS or?
Yeah, general CS. Yep.
Okay. Perfect. Amir, do you want to tell us a bit about yourself?
Yeah, sure. So my name's Amir. I'm an international student, second year CS spec. I like game development, and I work with Java, Kotlin. Um, I mean, I'm picking up Rust to like get into the low level kind of things, and in terms of security, I really like the hardware side of things or the low level kind of stuff. And I think networking would probably be interesting. So yeah.
Okay, perfect. Since I've just come back from training literally about mentorship and coaching, now mentorship is defined as a long-term relationship where you're trying to improve yourself in the current position. I'd say that this is more in line with coaching, where coaching is more of a shorter term position and it's about developing like some sort of relevant skill. With that being said, I was wondering if you guys have any goals for the summer, whether that be like getting some sort of credential, working on some sort of project, or anything. So Vish, you can start.
Oh, yeah. I'm just working on creating some custom mods on World Anvil and Forge, I guess. I've been trying to create like custom game maps and such, and trying to like set up more custom animations and such for my games.
Okay, perfect. Amir, what about you?
Nothing major in particular. I have a Rust project that I'm working on, like a Nintendo emulator. Yeah, that's pretty much it. Just trying to get that on my resume, get that done, and yeah.
Perfect. Yeah, doing a Nintendo emulator, you're definitely like looking to get sued, but sure.
I wish you luck, my friend. I truly do.
Thank you.
But it sounds like a fun thing. The only reason I'm asking is because the way, like how I got into cybersecurity was just doing a credential out of the blue in the field, and then getting hired like literally right away after getting that credential. So, like, if you guys ever wanted help on what credentials are kind of relevant and easy to get, I'd be more than
Oh, yeah, that would be great. Thank
willing
you.
to tell you about
Yeah.
those.
Yeah, that
Yeah,
would be
sounds
great.
good.
But the credential that I received, it was, I believe, last summer. It was just your typical Google cybersecurity course. I'd say it was a good introduction. Now, I didn't get hired because of it, but just because of the like basic skills that it gives you. Um, I'd say just the concepts are very fun. They go over all parts of security because security is a huge field with a lot of subfields, and it's difficult to figure out what you want to do. And it gives you a little bit of taste of everything. So there is a portion there for network security, and that's how I kind of realized that I really liked it, even though at the time it was probably the most difficult part of the course. That course, yes, Amir.
What kind of projects did you do before you get your first like internship or job related
Um,
to cyber?
I don't have many projects. Pretty much just everything that I did um, for hackathons. I believe the only one that's on my LinkedIn is, I think, Attentiva, and that was for NatHacks, using brainwaves to just make a focus app, which is barely stuff. But other things that I've worked about were also not security related. It was I'm trying to remember. I was trying to get into the health sector for a while, so it was an app that was I was making a pretty much a fitness tracking clone just to get used to CSS and HTML at one point.
Yeah.
And then your typical. Oh, and then my favorite project was making a insurance kind of rate predictor. There was a little bit of an AI component to it, but a lot of it is pretty much just using one huge formula, and then the rest was then the AI component was like more for like implicit things that would happen. So with the adjusters themselves, so that was the most fun part, and I got to work with some insurance guys on it, and they were really hyped to see it, and I got good results on that. But in the no projects in the cybersecurity field. All that happened after I got hired. But with that particular company that I work for right now, I was working for them as a in a different position, and then they realized that I was a cybersecurity guy, and they just recently had a cybersecurity incident. So they hired me in the position. So mine was a hire of convenience, but I'm very, very grateful for that. Now, the course that I will recommend for you guys to take. It's actually one that I'll be taking this summer, I think, if I have the time. I'll put it in the chat. It's from Cisco. I was talking to a lot of people on my military course. A lot of them are actually cybersecurity analysts, either for the government or for the military. And a lot of them were talking about that if you wanted to get in from zero, you'd want to do a Cisco network security course. So let me go find it real quick. So that's what I'll be doing just for fun. Here, so I'll put it in the chat, and you guys can take a look. But basically, it is a more complicated thing of what we're going to be covering weekly. I ideally don't want to be a lecturer. I would like to be more of a here's resources, and if you have any cool things you want to talk about, then we can do that. But I've been told by a few professionals this is a good place to start, so I'm taking it. And I believe that Coursera has a 7-day trial, and I've speedrun courses in 7 days before, and this is one of the smaller ones. So I think if you ever have a week where you're not doing anything in the summer, do that free trial, and I'm sure that you could just speedrun the entire course in 7 days.
Don't you have to pay for like the certificate though? Still, or am I mistaken?
I'm not sure. I never actually fully speedrun a course in 7 days, so I'm not sure if you'd have to pay the certificate. Either way, it's $60, I believe,
Oh,
then per month. So if you speedrun the course, then pay $60 for monthly subscription just to get the thing, cancel subscription right away, then I feel like it would be worth it. But one of the things for you guys to look out for if you ever want to get more into the field. really made me more comfortable with talking about things, and that's how you get positions. So, also talking to some of the professionals. Let me look at my notes here. If you're going to be going into cybersecurity, you guys want to search up DevSecOps. So that's cloud security, pretty much. Apparently, the government has a very big emphasis on that currently, and not a lot of guys that are there have that capability. So if you wanted to look into cybersecurity as a career, search up DevSecOps.
Got it.
Based from my conversations. Okay, that kind of leads us into the mentorship mission. So my mentorship mission is just pretty much getting to know you guys and then trying to just keep tabs on you, seeing what you guys do over the summer, whether that be your Rust Nintendo emulator or whether it be like the course and stuff. I'm just here to be a useful guide, kind of introduction to people, because I know quite a lot of people in the field. So, and if you guys ever have any questions or anything, feel free to ask. Just being a resource for you guys. That's pretty much my mentorship mission. Now I'll have these kinds of presentations, maybe with some common concepts from network security, something fun that I think I want to talk about, but I don't like being a lecturer because that's what I already do. And then setting mentorship expectations, same thing. Just feel free to reach out to me at any point in time if you're ever struggling or anything. I don't have to learn your names because I can see them on the screen, but basically I'll just keep notes on you guys, and then we'll just do check-ins every week just to make sure that things are happening, because that's sometimes what we need over the summer, unless you're already swamped with work. Okay, so we're going to move on. So I mentioned content breakdown. So we have applied network security because of my position. And then we have research and network security. So if you ever wanted to get into kind of more of a research side of thing, I know most of the cybersecurity profs. I haven't had the opportunity to speak to one of them because she's always gone, but I know a lot of profs and what they like and what they enjoy. So if you ever want to know how to talk to a prof, just let me know. Now, usable privacy is part of the lab that I'm working with right now. Privacy has been a growing concern in the EU, as I said it prior. So if you guys have any questions about that or anything, also let me know. I believe that my next presentation is going to be more privacy related, just for you guys to get the hang of it. And then ideally I'd want to do, oh, there you go, modern cryptography principles. So if you guys ever wanted to take 496, which is a temporary course, but it is one that's done by my research supervisor, and it's about cryptography principles and modern cryptography. So unlike 331, I believe, which is the older cryptography, 331 goes over, unless that's the networks one. I forget the difference between 331 and 333. But the cryptography at the 300 level one is more about like old cryptography, like your Caesar cipher, your shift ciphers, like stuff you'd see on CTFs and stuff. But 496 is really nice because it talks about like modern cryptography principles, like the Diffie-Hellman key exchange and all the patches that happen to it, and gets into a lot of like inference attacks and stuff like that. And I really enjoyed the course. It is a little bit challenging because you have to think outside the box, but one of my presentations will probably be on cryptography, trying to get your feet wet in the field, telling you how the math works and stuff. It's definitely more of a passion project for me. And then task planning and leadership. So I've touched on that. Just we'll set some goals for the summer, and then I'll just check in with you. That's all that means. And deciding a mentorship breakdown is just, I want to know what you guys want out of the mentorship, whether it's more of like a conversational check-in or whether it's more like lecture based, what you guys are interested in. So at this point, I'll probably open the floor to you guys. If you guys want to talk about what you guys want out of this, because I'm pretty much just here for you guys.
I'm fine with more lecture-based stuff. I mean, just starting out.
Yeah, it's just understanding where we should first take our steps into this kind of field, and like what are the basics that we should know about it would be really helpful.
Lecture based understanding. Six for the field. Okay. Sure, I can do that. Then in that case, I'm guessing that it'll be a little bit of a flavor of everything. So I'll probably push network security the most because that's what I like to do. But I'll also mention privacy and cryptography and the research side of it just for you guys to know about. So move on. Let me see. My notes aren't popping up. Put them up on my phone here. Actually,
Do you know that a lot of air traffic control still uses floppy disks?
yes, I'm inside of towers at some points in time. I had the opportunity to have a scholarship to go and learn ATC stuff for 8 weeks in Ottawa. So they do use a lot of floppy disk, but it's mostly for redundancy.
That's fair.
I wonder how I can pop up if I do slideshow with notes.
It's weird. Why don't we ever use Discord calls for this one? Is it because of the recording factor? Or?
We could use Discord calls, but I think it might be due to the recording factor. I've just kind of been going along with what I'm told, so.
Oh, makes sense.
Getting my hang of things because I've been in Edmonton for a total of like 2 days. Okay, network site review. I think I've read through the material that you guys were given before, and it was the TCP/IP stacks and stuff, so I won't be covering that. But network devices. So network devices is just anything that maintains information and services for users of a network. As we all know, they can either be connected wired or wireless to networks. And the overall network infrastructure is how we communicate with the internet. And we'll get into what a typical network looks like in, I think, the next slide. Let me click on the thing. So simplified diagram analysis. So I don't usually use this in my field, but I do make network diagrams just to explain how things go. I don't usually use the phones and stuff, but basically what's happening in this diagram, this is what your typical like home network would look like, not really an ISP, which is internet service provider, or an enterprise level network. But in this home network, what we have is perfect. So we have a firewall, which we'll get into a little bit later, and then we have a router. So the point of a router is to direct traffic to devices on the home network, which can include all the devices that are on there right now. The server here is more like a file server. So that allows all devices on the network to access the files in the server. So I was talking about my home server earlier. It would be kind of like that. In this diagram, you also have a switch, and switches are more of like an enterprise thing. So if you look at your router back home, most routers are switches inherently. But for enterprise level communications, you'll have a lot of switches. So if you ever look around the new building, especially in UCOM, into what's it called? On the ceilings there, the things that are there are either Wi-Fi extenders, which are also routers, or switches. And how you'd know is, I believe they look the same, but there's a different thing at the end of their warranty seal. So if you see -R in the end, it'll be a router, or -S will be a switch. So that's a little bit of a thing. But switch is just basically allows a lot of devices to connect to a router efficiently, and we'll also talk about what efficiently means later on. Yeah, and it just provides additional ports and Ethernet connections, so switches are not really required. And then if you see here, there's two routers. Actually, there's a router that's connected to the switch on the top, and there's a router that's connected to the bottom. That's more for load balancing. You usually want to have your wired and wireless connections separated because it takes a big toll on the router. So we'll get into more of that. So identify network devices. So we have all this. Perfect. There we go. So the one thing that I haven't mentioned here yet, it is. Okay, I actually wonder. Grr. My notes go away every single time. Let me see. Oh, now they're here. Let's go back. Okay, diagram, networks. Okay, so here's all the devices and stuff. We've already covered most of them. The only thing that I'll have is a wireless access point. So the wireless access points are more of a new development, I want to say. They are specifically designed to receive and send digital signals over radio waves, creating a wireless network. This sort of mimics if you ever hotspotted off your phone, it technically becomes a wireless access point because it's using radio waves, or sometimes Bluetooth to share data. So devices with wireless adapters will connect to the access point using Wi-Fi. So. And then Wi-Fi is just a set of standards that are used by network devices to commute wirelessly. And yeah, so basically the whole flow of the system here would be that the wireless access points and the network devices will commute wirelessly with each other using radio waves. And then through the wireless access point, it will send data to routers and switches, which will direct them to their final destination here. So we're going to move on to local area network. So it's more of an activity. Let me see. Perfect. So this is a little bit of a diagram of a simple local area network. And then you have all the devices here on the left. So what do you think will go between the two firewalls and the server?
Would it be a switch?
It would be a router.
Oh, okay.
The switch is more for we'll talk about network zones later, but the switch is more for like internal communication. So the switch is actually what's going to be down under the firewall. Yeah, so we'll have a router that's between the firewalls and the server. Then a switch that'll be inside of the firewall, inside of the kind of containment area. So that'll be the question mark underneath, and then the four missing from the bottom are just devices and that are connected via the switch. And then you have a wireless access point here on the left side under the server. I wonder if I have.
What would the difference between a router and a modem be, specifically?
Sorry, could you say that again?
What's the difference between a router and a modem?
Yeah, so a modem would be kind of outside of here, so it connects your home network to the internet. So it's kind of like the highway outside, and then a router manages how the devices in your home network talk to each other. So what will happen is, um, we'll talk about IPs later, but what a router does is it will connect all your devices to a central point. So let's say you have your phone, you have your laptop and stuff, they'll all connect to the router first, and they'll be given their local IP addresses. Now, if any of them want to talk to the internet and not to each other, what you'll do is the router will send a signal to the modem, and then the modem will translate your IP address from an IPv4 address, that's your local one, to a scrambled IPv6 one, so it can't be traced back to you, and then it'll send a request out to the server somewhere else.
I'm sorry, I just need to. Oh, thank you for the explanation for the both. Yeah, sorry.
No, it's a good question. I don't think I covered the modem at all because it's not on my diagrams there. But yeah, modem is just like a translator pretty much for your IP addresses and everything.
Okay, cool.
So in most scenarios, modem and router are synonymous because they'll be in the same box. But we'll go to just a quick note on security zones, as we've talked about. So security zones, as we were talking about Linux and the app segmentation, we want to do that here. So we like in CS in general, in networks and pretty much everywhere, we like to have encapsulation. So if you talk about the OS, making it seem like each application has its own access to all the resources. If you ever taken 379, if you talk about using using VMs, using virtual machines, that's also a version of encapsulation. We like encapsulation, and there's encapsulation in networks as well. So encapsulation network environment will usually be called security zones. And security zones are basically segments of a network that protect the internal network from the internet. So they are part of the security technique. So network segmentation is a technique that divides the network into segments, and security zones are how you do it. Now, there's multiple ways to do it. One of the most common ones that you'll see in kind of enterprise scenarios would be subnetting. So where subnetting is, you're dividing a network into logical groups called subnets. Now, those logical groups vary. It depends on whether you value privacy and security over convenience. But it works like a network inside of a network. So subnetting divides up a network address into smaller subnets within the network. So as we were talking about with the modem and the router will assign IP addresses to all your devices, local IP addresses, and the modem will translate them into external IP addresses and also shuffle them around so it can't be traced back to you. With subnetting, basically think about it as a level lower than a router. So now a router has to manage like subnets, like zones. So let's say like IP address 1 to 500 is one subnet, and then a router will treat them as a different entity. And then IP addresses like 501 to 1000 is a different subnet and stuff. So
Yeah, so I just had a question on subnets. Kind of two questions. One, what would like the layer in the like network model layer, would that fall under subnetting?
I don't think it would be covered by it because it's not outbound yet.
Oh, okay, I see. Okay. And then also, what kind of guarantee do we have that, like, so if I'm in like one subnet, what is my guarantee that, what is the guarantee that I can't like breach the second subnet? Like if it's all in a single point of failure of like the router, if the router is compromised, then I have access to all subnets, right?
Yeah, so that's the thing. You don't. It depends on whether your network security guys are solid in what they're doing.
Okay.
Usually the IT team, but the whole point is to give you, because think about it like using a VM. There's no guarantee that your VM can't leak into your machine because it still runs on your machine, right? So it's kind of the same guarantee where you're encapsulating, traffic from one subnet, and it's supposed to not breach into other subnets. But obviously we saw what's it called, the most famous example would be I think it's Forex hack. In that one, multiple subnets were broken into, so you'd have to look at what the commonalities were between the subnets and then why they weren't segmented properly.
Okay, got it.
But yeah, and then the most popular way of doing subnetting is classless interdomain routing. Let me see. Before we get into that, we can get into classful addressing. So classful addressing was something that was used in the 80s as a system of grouping IP addresses into classes, and the IP addresses would be classed from class A to class E. Now, at that point in time, they weren't really using the port model that we do now, so this is mostly gone out. So each class from class A to class E would have a limited number of IP addresses, and then because of how big the internet has gotten and because of how many devices we're using, all of these IP addresses, because they were IPv4 and segmented into these different classes, one class may be depleting all of their IP addresses faster than the other classes, then you just run out of IP addresses to use. So that's why we switched over to classless interdomain routing. So classless interdomain routing is a method of assigning subnet masks to IP addresses to create a subnet. So there's an example below, but we'll continue here. So it just allows cybersecurity professionals to segment classful networks into smaller chunks. So let's say you have like a class A, and the reason we still use classful addressing, even though we don't really talk about it anymore, is for backwards compatibility. But let's say we have class A to class E classful addressing on a network, then we'll be applying classless interdomain routing to kind of extend a class if a class requires more IP addresses. And we'll see an easy example down below. But so the IP addresses that are generated by classless interdomain routing are like IPv4 addresses, but they have a slash followed by the number at the end of the address. And this number is just a prefix. So if you look below, we have that a regular IPv4 address uses kind of the format down there below. And a CIDR IP address would include the IP network prefix at the end of the address. So let's say that /24. And then based on that classification, this address will encompass all IP addresses between 198.1.1.8.5.1 to 255.
How is the number 24 determined? Like, what if I put like 25 or?
It doesn't have to be
16?
24. That was just for the example. It could be 1. So
Okay.
24. If you're just going from 1 to 24, which you usually don't want to do because you don't want to leak any information about the subnetting with just the slashes, so you'd usually use random numbers there. But the 24 is an arbitrary number. It could be /100.
So it doesn't determine like from the 198 51 100 dot like 1 to some specific number.
Yeah.
The 24 is just like an identifier of sorts, or
Yeah, it's an identifier.
okay,
So it just identifies the subnet that you're in.
I see. Okay.
So you'd be in the 24th subnet here.
Okay. And what would is there a limit to how big the subnet could be? How big that number could be?
There's no limits to how big a subnet can be, but obviously you want it to be less than the all set.
Yeah.
So what I've seen in enterprises is that I've had the opportunity to go look at how Cisco networks operate. So they have like hundreds of subnets for each like small little thing, because they designate their employees into like clusters and they don't know about it. And then if one employee, let's say, clicks a phishing link, they're only connected to like 100 subnets. So then only that subnet would be compromised. But also back where I work, we only have like 3 subnets, and it's based on like what position you have.
Okay.
So it's up to implementation and how much bandwidth you're willing to spend on this.
Okay. And this is all implemented on the organization's router, right? Or the switch.
Yeah. So
yeah.
The router would be the one translating. So the router would have a translate table, and it would be able to map all communications back and forth. So
makes sense.
Okay, and then we'll just get into just a tad of privacy here that I wanted to put in the end, and then I'll talk about attacks and stuff probably in the next time. But so you've obviously heard of firewalls. We mentioned them before. So firewalls are pretty much appliances or hardware devices in the old times, and they inspect and filter all network traffic before it's permitted to enter the private network. Now, what this does is it also segments, if you go back, it also segments networks into different security zones. I do not remember their names, but basically, in a general sense, there's 3 security zones. There's okay, maybe I'll talk about them later.
Okay.
But there's an outside security zone. Don't quote me on it, but there's an outside security zone that's the entirety of the internet, and that's what you're trying to filter through. Then there's a demilitarized zone, which is the zone between your firewalls. And then there's an internal zone, which is your network. And then usually that internal zone would be split into different zones as well, depending on how much security you want to provide to it. And they all have their own names. I'll brush up on the names and add them to the other slides. But for firewalls, so traditional firewalls, also back in the 80s, were configured with just rules that tells it what type of data packets are allowed based on the port number and IP address. Has Manan talked about ports and packets?
I don't remember exactly. I think he mentioned about it, but didn't go too much in depth. But I am familiar with the topic.
Okay. I'll take a note for me to talk about that. Yeah, so different ports use different or allow different
packets.
Yeah, different packets, and they're used for different reasons.
Oh yes, he did mention it. So 80 was HTTP, and then 433 I think was HTTPS and whatnot. I'm pretty sure you did mention this.
Mm-hmm. Yeah, so in typical service, that's what occurs. So a firewall, let's say you're sending a packet that's huge, let's say up to the MTU, which is the biggest byte pattern that you can provide, that you can send over, which is 1500 bytes. If you're sending that to let's say a mail port, obviously that's not going to fly because mail doesn't require such big packets. So a firewall might block that and inspect it further. But those are traditional firewalls. In today's world, we have let's talk about, okay, so stateless, that's the predefined rules. So a stateless firewall is the one that's just predefined rules. You have a coder that writes it in the background, and it does not adapt in any way. Then you have a stateful firewall, which is a class of firewall that keeps track of information passing through it and proactively filters out threats. So this is also a kind of non-ML approach.
Okay.
Basically, you're having another table keeping track of the history of the typical packet that arrives at this port, and then if something is classified as atypical, it will filter it out. But in this case, you have much less intervention because you're not writing those rules itself. It sets the thresholds and stuff based on what it's seen before.
Okay. But you could probably configure what is considered atypical.
Yeah. So for all of these, you'll start like with a baseline, with a base truth, and then it'll just adapt based on the typical traffic that arrives.
I see.
Yeah, so it uses something called a state table to track connections, so it can match the traffic and match the behavior of the traffic to a particular session. And then we have the next generation firewalls. Now, these are mostly ML based, but they don't have to be. So next generation firewalls include deep packet inspection. So deep packet inspection is big in the cybersecurity research field because it's trying to infer things from the encrypted packets themselves. So without breaching the encryption, you're looking at the metadata that's provided by the packets, and you're making inferences back based on that. So that's deep packet inspection. And they also might have IPFs, or intrusion prevention features, which I'll actually note down. That's a fun topic to talk about. Intrusion prevention. And basically, they'll actively look for whether the network's being intruded or not, and that's covered in intrusion prevention methods. These days, a lot of deep packet inspection is done with ML, mostly deep learning, actually, because it can identify patterns that we as humans just cannot identify. So obviously, you'd have your like handcrafted features that you'd be looking for, but also a lot of these approaches now use deep learning to pick up on patterns that we're not able to. Yeah, and then you have proxy servers. So actually, you've set up a proxy server if you've ever set up a Minecraft server or any game server. So basically, they use network address translation to serve as a barrier between clients on a network and external threats. Now, we do this inherently when we use a modem and a router, because your local IP address is not connected to your outside IP address.
Yeah.
So a proxy server kind of does the same thing. And then you can have, they're split into two types, but usually you'd have both. So you have forward proxies that handle queries from internal clients when they access resources to an external network. So forward proxies is like you're trying to access, it's pretty much like you trying to access the internet, and then instead of your IP being out there, it would be a translated IP address of something else. So the proxy server. And reverse proxies is just handle requests from external systems to services on the internal network. So let's say like you're running a server. You're running a server, and for an additional layer of security, you're running a proxy server as well to maintain like the privacy of the clients that are accessing your stuff. But usually if you see a forward proxy, you'd see a reverse proxy because they're easy to set up if one of them is set up. And then the last thing, I hate that I do not have any time to talk about it because I'm over time, but
that's fine.
VPNs, that's obviously my research my research field. I'd love to talk about VPNs for a very long time, but basically VPN is a service that encrypts data in transit and disguises your IP address. with a huge asterisk. VPNs use a process called, so I'll just read off my notes and then I will give my actual opinion on it. VPNs use a process called encapsulation. So we've already talked about encapsulation, how it's used everywhere, but encapsulation wraps your unencrypted data in an encrypted data packet, which allows your data to be sent across the public network while remaining anonymous. VPNs protect user privacy by concealing personal information, including IP addresses from external servers. A reputable VPN also minimizes its own access to user internet activity by storing strong encryption and other security measures. Now, that entire thing has a huge asterisk on it because VPNs are not as useful as the general populace thinks they are, because a lot of their services like obfuscating. You don't want to know. You don't want to have your you don't want to have your like internet service provider or like your boss or anyone sniffing your packets to know what you're doing. But a lot of the research in the field with 97% accuracy can figure out what specific application you're using, even if you're using industry standard VPNs, just based on fingerprinting and other methods. So it has a huge asterisk. But in theory, when you send a packet over, the packet will have a lot of information in the header. It'll have your IP, it'll have the server's IP and stuff like that, and a lot of that stuff is stored in plain text. While the contents of your packet is encrypted, right? So if you set up a sniffer with, I believe you guys were sent a link to Wireshark. Very easy. Connect to a network, set up Wireshark, and now you're seeing every single packet. And you're also able to track them into things that we call flows, because you can't just send one packet. You're usually sending a lot of them. So a flow of packet. Well, you can't see what's being sent. You can see where it's being sent, what port is being sent to, where it's being sent from. Now, the IP address that it's being sent from is usually dynamically allocated, but it doesn't have to be. So you can infer, like, let's say if you're sending something to port 443, you're making an HTTP request. Like you can start making these kinds of fingerprinting requests. So what a VPN in theory should do is, on top of like on top of having just the data being encrypted, what it should do is it should wrap your packets in a bigger, usually VPN packet, and then the entire packet's encrypted.
Okay, that makes sense.
And then on top of that, the communication happens in an encrypted tunnel. So basically, you have to break the encryption of the tunnel first, and then the encryption of the VPN packet, and then the encryption of the packet to find out, like, it's multiple
so it's
layers. But the thing is, they do not think about metadata and how many packets are being sent. What's the latency between packet to packet? Just all this metadata leaks a lot of private information.
Yeah.
So with things like, I often single out Netflix, because Netflix people can classify with the worst ML classifiers on like a 97% accuracy, even with a VPN, because Netflix forces you to have standard lengths of packets. So if you see a lot of packets of the same size, and it's usually 1,300 bytes being sent on a consistent basis, you're watching Netflix. So, and there are ways to get around it, like padding. So you can pad or splitting. So you can split their packets into two smaller ones, into many smaller ones, and then reconstruct them at the point of contact. Or you can pad more stuff to the packet. So if you're sending small packets, you send larger ones sometimes. Sometimes you delay sending them, but that also introduces latency.
Yeah, because it's
you're using more bandwidth. Yeah.
Okay, it's pretty interesting stuff.
I believe that's the end of my presentation. I'm only a little bit over time, but
it's fine. I actually enjoyed the last bit.
Well, you can tell that I'm very, very interested in the last bit because of the amount of papers I've read on it. But, yeah, we can get into a lot of more fun things. It's just there's a big base here that I have to cover first. So
yeah,
because I can't assume that you know what a router and a modem is, and when I start talking about packets and using ports, you have to know that it's sent to a modem first and then
Yes.
translated over. Like, yeah. But anyways, it was fun.
Yeah.
I believe it's just me and you on the call now, but hopefully we have a better turnout. Also, make sure to sign up for or do the crab meet, or when to meet for the Donald Ashdown presentation, because he's one of my good friends.
Where's that?
In the main CHADS.
Okay.
Thing, yeah. It was supposed to be just pretty much a stand-in for my presentation.
Okay.
But I decided to open it up to all of CHADS, because why not have a U of A ISD professional come up and talk to us, right?
Yeah.
So, but anyways, make sure you do that, and then I'll send stuff out about the next presentation
Perfect.
at some other point in time. Okay.
Thank you so much.
Do you have any last-minute questions?
No, not really. Well, probably one. Will we work on any like practical applications, or is it mainly just theory based? I would love to get like my hands on something tangible to say like, oh, hey, I did this. I mean, the mentorship is great and all, but I'm more of a like practical learner.
I can do that on a very low level. I can get you guys to do a risk assessment, so I can give you guys like a scenario.
Yeah.
And then you guys fill out a formal like cybersecurity risk assessment. That's like 60% of my job.
Okay.
I'm sure that I could also come up with something practical for you guys to do, but I'd have to
Sounds
think
great.
about that.
All right.
All right.
Thank you so much.
Yeah.
Have a good weekend.
Yeah. You as well. Bye.
Bye.